sorry, I managed to mute myself by accident there. Right, new networks mean new security challenges. You probably all know this. You know the changing dynamics, the complexity, fragmentation, etc. And you probably know that the general consensus is it's not if you will be breached, it is going to be when you're breached. A sentiment backed up by everybody's friend Gartner, and there's basically saying, you know, accept the reality, you will basically get breached, and that we need to adopt new ways of dealing with this that enable the network to be an integral part of the strategy that fixes what's going on. And the reason for that is you cannot protect what you can't see, and fundamentally, it is the network that sees everything. If the network hasn't seen it, it's not gone across the network, it's not spread, it's not causing you the same level of issues if it had just been stuck on one machine in the corner. So the key, and certainly the key as far as StealthWatch is concerned, is visibility from the network that allows you to see exactly what has happened, when it happened, and who it happened with. This session is going to look particularly at some insider threat and is basically a session about how we can use network analysis and the network, which is our obvious thing in the quote given there by Sherlock, to mitigate an attack. So let's start by looking at our insider threat and how we manage it. The next few slides form the basis of how some of the different ways that we can protect our network and where exactly network visibility will fit into it. So we use the analogy of you arriving at the airport. So you show your document, your passport, boarding control to the nice gentleman at security. He then lets you through. Basically, we've used access controls to control who is and who is coming into the network, that you are who you say you are. And then we've segmented that network into land side and air side, and based on your credentials, you're allowed one side or the other. In addition, we then put some content inspection in. We do inspect exactly what's going through those at the particular pinch points, and this gives us, in this case, using firepower, this allows us to control what you are bringing in to that secure zone or the secure part of the network. Finally, once you are through into that side of the area, into the network, we're going to monitor for security visibility, and that's where StealthWatch comes in using the NetFlow. A brief introduction to NetFlow, and apologies for those of you who already know NetFlow in depth. Some of this is going to be a repeat for you. Developed by Cisco as a way of producing statistical reporting, way back when, 20 years ago now. It is based on the flow of data and is not on a per packet generation. So you can generate NetFlow on every X packets, etc., which is called sampled flow. And I'll come on to some of the differences between sampled and full NetFlow in some later slides. There are a variety of versions, the main ones basically being version 5, which was the most popular, and version 9, which is the most current in Cisco world. Version 5 is the traditional NetFlow. It's fixed, defined flow, defined fields, and flexible NetFlow actually allows you to be a lot more flexible, as the name suggests, in terms of what you put into the fields and how you define a flow. A couple of things about NetFlow. If I'm going from my nice PC on the left to my server on the right, and I go through one NetFlow capable system, it is going to generate one NetFlow packet for the traffic going from laptop to server. It's going to tell me what interface it's gone through, it's going to give me the source IP and ports, etc., destination, protocol, the packets and bytes sent, and if I have a TrustSec enabled device, it's going to tell me what my security groups, my TrustSec IDs are. The return traffic, i.e. when I'm pulling a web page down, etc., is going to generate another NetFlow packet for every NetFlow capable device it goes through. The key with NetFlow is it provides us a lot of information and it gives us that visibility. So it tells us who is connected in terms of the IP addressing. It tells us where they've connected in terms of particular interfaces, so we know what route they've taken through the network. It will tell us what port they've used, which will give us an indication of the application. If we have an N-bar capable device, it will actually tell us what the deep packet inspection has generated in terms of an application. It will tell us when it's done it, and it will tell us how much it's gone through. All of this obviously tells us a lot about what is going on in your network, and one of the key bits is it is telling us what's happening on your internal network. We're not reliant upon your perimeter devices for this. We're using your infrastructure. The east-west visibility is there as well as the north-south visibility. A quick bit on the deployment architecture. You need a flow exporting layer. You need something to basically generate the NetFlow. Most Cisco kit will do this as well as a variety of other vendors, and we can talk about that in a bit more detail later. That flow gets sent to a collection layer that collects, stores, and analyzes those flow records. And in the StealthWatch case, that then forwards metadata about those flows into the management console. And that's where we have our managing and reporting layer. That's where you run your queries, etc. You can have a variety of different flow collectors. You may have more than one for a number of reasons. Possibly for topology. If you've got two big data centers, you probably put a collector into each one of those. Possibly for capacity. The flow collectors come in different sizes and can support different quantities of source devices and volume of flows. But all of those feed into a single management and reporting layer, so you've got centralized reporting across the whole of your network. There are some considerations we need to bear in mind when we are dealing with NetFlow, and in particular with the exporting layer. And I'll go through these as we go through, but they are basically, does your device support NetFlow? Which version of NetFlow do we want to use? What do we need to configure? What do we need to measure? And where in the network do we want it to enable the NetFlow export? Because there are a number of different options and they have different impact both on what we see and on how much we see. As I said, there are a number of different versions of NetFlow. Version 5, which is pretty much the most common one that went out in the late 90s, etc. There are 18 exported fields that we all use. It's the most commonly used. It has two key limitations. One is it only supports IP version 4, and the other is that they are fixed fields so that you can't add in extra information that you may want. Version 9 is template based. It will support IP version 6 flows. You can determine what fields you want to put into that, etc. Flexible NetFlow is a version of version 9 in effect. It's slightly less common. There is an open standard, which is effectively the flexible NetFlow as an open standard under the RFCs as you see there. IPFix it's called. It will allow you to support things like N-bar2 information. So that's where you're using network-based application recognition. So some of the Cisco devices, etc., use it, as do other vendors, so that they do a deep packet inspection into the traffic, so that they then say, okay, looking at this payload, the structure of this payload, etc., although this is on port 80, I'm going to say this is actually Skype. So you can be much more specific about what the applications are with N-bar2, and IPFix will allow you to put that information into the NetFlow packets that get then sent to the collectors, and we can use that for security analytics, etc. later. NSEL is a Cisco-specific form of NetFlow or structure of NetFlow based on NetFlow version 9 that comes from ASAs. The big advantage of that is that it includes information about the pre- and post-NAT mapping, so that when a host has gone through to the internet, we can tell you what the true destination was rather than the fact that it went to the proxy, etc., etc. So they're the different versions of NetFlow. There are essentially 3 layers at which you can deploy NetFlow, and you may or may not deploy some or all of these depending on the requirements. There's the access layer, your distribution stroke core layer, and then on the edge itself. And they offer different capabilities and different benefits. So where to collect from? If you're looking for security, we only need to account for that flow once. If we want to know that A has spoken to B, we just need to know from the edge, so from the access, that actually that flow has happened, that my laptop has made a connection out to the internet or a connection to the web server, etc. So if you have that ability, then you would collect that data at the edge. However, quite frequently, the access layer switches will not be the most sophisticated switches, and therefore they may not have that NetFlow capability. In which case, you want to try and collect that data from the distribution, and failing that, collect it from the core. If you collect it from the distribution, you should still see virtually all of your traffic, and therefore you will generate the flows for all of the connections. What you are going to miss is anything that goes into an access switch and back out the same access switch. So you are reducing your security, but what you're reducing it is basically into a self-contained, fairly small constrained area. And if you have ended up being breached, you would expect whatever malicious activity is going to happen is going to spread beyond that access switch out through the distribution or the core elsewhere. So it's not it's not a disaster by any means if your access level can't support NetFlow. It is our preference because that means you've got 100% coverage, but if you can't, then getting it from the distribution or the core will give you pretty much the coverage that you need. Also, we want to get it from any perimeter device where possible so that we get information on traffic that is going out of the network or into the network, potentially even more critical. And particularly where we've got NAT and proxy information, etc. So that allows us to see what the true end addresses are, as I said, rather than thinking, okay, this device has just gone to the proxy, etc., etc. If you are looking for in-depth forensics and full auditing, then you really want to get every single packet. So you do want to be deploying it as close to the edge as you can, and in an ideal world, you probably also want to be getting it from the distribution and the core. And if you're looking for networking, i.e. performance management and performance measuring, you definitely want to be generating NetFlow from pretty much every interface, interface that the traffic's going to go through, so that you can have accurate measurements based on time, etc. And you can also then do some accurate utilization in statistics on the interfaces, etc. So you can do trending, capacity planning, etc. This presentation is fundamentally about the security, so we're back to the top case where actually we really, we only want to see it or only need to see that packet once. Hopefully that was clear, and if it isn't, we can cover it in the Q&A. There's a slide here with bits of NetFlow terminology. I won't go through it too much. The key bits are the flow. So a flow is defined by a set of key fields. In the StealthWatch case, we define a flow as the source and destination, IP and port and protocol, as well as the interface. So we generate a record for each flow. and we'll go through that in a bit more detail. A couple of quick myths. NetFlow impacts performance. On modern infrastructure, NetFlow has zero performance in terms of your resources because it's generally implemented in hardware. There's a separate ASIC that's doing the work. If you have got older equipment and it's been generated by the CPU, it's a software implementation, then there is an overhead on that CPU, anything from 5 to 15%. If it's getting up into the higher percentages, that's generally because your CPU is already busy and you should possibly be thinking about having refreshed it anyway. The second, NetFlow has a bandwidth overhead. It has very, very minimal overhead on the bandwidth. We're generating a small packet every minute for each flow. It is a very small percentage, as it says there, less than 1% of the traffic per exporting device. So go back to the NetFlow collection. From our earlier diagram, we had a connection from the left, went through, and a response from the right. But there were two unidirectional packets that we stitched together into a bidirectional packet of flow record. This makes it a lot easier for visualization, and it makes it a lot more useful for analysis. In addition, we need to do deduplication, which we do. If my packet is gone through multiple switches, I'm going to get multiple packets that I need to combine everything, validate it all, and from there, I add and create, rather, a conversational flow record. And this is for a number of reasons. One is, it is just much more useful for doing analytics on a conversational flow record than it is on multiple flow packets for the same conversation. It's easier for us as humans to understand, and it gives us that basis for doing some of our calculations and running our security algorithms. The conversational flow record tells us when, it tells us where, it will tell us what protocols, it will tell us what peers it went to. It will only tell us who, as in the user, if we have an integration with some other systems that are basically going to tell us and map IP addresses to usernames. Essentially, the standard integration for us would be Cisco ICE. We can also provide integrations with other Active Directory or authentication systems. But that who does come from an external source because it is not within the NetFlow information. One of the other big benefits of NetFlow is that it doesn't have to look into the payload. So, in fact, it doesn't look into the payload, generally speaking. So you have no problems if the data has been encrypted, etc. You have no decryption issues, but you also have no privacy issues. And certain parts of the world, monitoring user traffic and being able to pick users, etc., out of the data flow is not well regarded. You can get more context, you can pull out more details. Some of this context that we have there comes from the StealthWatch system itself, such as the host groups, which is where logical grouping of devices, which I'll talk about a bit later. The TrustSec IDs comes from within NetFlow. The RTT and SRT calculations come from within the StealthWatch system based on the flow traffic and how it's worked. The other advantage of these conversational flow records is that they are quite compressible and means that you can store them for a longer term, generally much longer than you would if you have multiple flow packets. So that in an ideal world, we generally try and size the systems to store these records for 12 months. So that you've got a full audit capacity for 12 months. And if a breach, when the breach happens, you want to go back and see if there's been similar traffic patterns, etc. You've got a good basis, a good pile of data to go and do that with. Host groups are where we apply situational awareness, as it says. It's a virtual container, so it's a logical container. You can see the sort of tree structure on the left-hand side there. You've got the inside hosts, outside hosts. You can break it down into functions, servers, users, etc. And you use IP addresses to create the different host groups. So in this case, we've got a lab server with a range, an IP4 range. Any host can be in multiple host groups. And we use the host groups for two reasons. One is it's a lot simpler, a lot more understandable from a human point of view to look at this and say, okay, that's a lab server, rather than look at 10.11.0.1 and try and work out in your head that that's a lab server. The second is that when we baseline the traffic for behavioral anomalies, which I will come on to, we do it both on an individual IP address level and at a host group level. If you think about it, the behavior of a device that's in your DNS server's host group, you would expect to be different to the behavior that you would expect in your web server's host group or your domain controllers. So we use these host groups to also create our behavioral anomaly detection. So if I suddenly see a whole pile of DNS traffic from my DNS servers, I'm not surprised, because actually that's generally what I've been seeing from my DNS servers. Whereas if I suddenly see high spikes of DNS traffic from my web servers, that is going to be an anomaly, that is going to flag up. Another way that we add context is through the integration with ICE. We only need ICE in monitor mode. For those of you who don't know ICE, this is our Identity Services Engine. You can run it in monitor mode, and typically that's how it's initially implemented. So it doesn't actually obstruct access, whatever, but you get profiling, you get posture assessment, you get visibility, and you get additional visibility over what you would get from NetFlow. So you're getting visibility about operating systems, usernames, etc., etc. And that information is what we add in to the flow records, so that when you look at a conversational flow record in the console, where we have that information, we will append it in there. So we can tell you what the MAC address is, we'll tell you who the username is, etc. Again, all of this helps when it comes to using the algorithms and for looking at data for security points of view. The final area where we add context is with Slick. This is StealthWatch's, or Langcoats as was, own threat feed. It comes off a third-party source, or a number of third-party sources, includes things like botnets, command and control servers, Tor entrance exits, etc. And that information is constantly updated and obviously is used, so if anything generates a connection to one of these known sites, etc., that context adds information, it will generate an alert, etc. We are going to be switching across to a Cisco Talos feed, which is probably somewhat more comprehensive, in the second half of this year, as part of the integration now that Cisco own Langcoat. So here's a conversational flow record with added context. We've added the geo-IP mapping, so we know that address is in Russia. If you look on the peer details, the threat feed said that actually it's going to Gumbler. We know from the flow sensor, which is a packet inspection device, what the URL payload was. We know what host groups they were in from well, we have additional information because we know what host groups they're in. And if we have it, the application information from NBAR and the username, etc., from ICE. So we can add extra context to all of these systems, all of which makes it a lot more efficient and makes the algorithms obviously more accurate and gives you more to go on when you are finding an indicator of compromise and are wondering what exactly is going on. Just to say, we will support IP version 6. No problem, that's already within the product. So by using NetFlow, we've collected a load of data, or evidence as Sherlock would say. we're now going to do some analysis with it. This will help in 3 key areas. It helps us in the identifying what's going on in the network. It helps us in terms of any indicators of compromise, in particular from any breaches of policy segmentation and from the network behavior and anomaly detection. And the audit trail gives us a better ability to respond to an indicator of compromise. I'll go through these 3 in a reasonably high level to give you an idea of how we do that. Within the console, we can locate the assets, we can search down, we have a lot of host information, we have a lot of reporting. You can determine which are your top hosts, which are your active hosts, which devices have actually been sending the most traffic. You can run all of these reports on host groups. So you can say, okay, who's talking to my web servers the most, who's talking to my PCI servers, etc., etc. You can pivot onto the transactional data and you can find hosts by particular applications. You can track them down by saying, okay, what traffic on what application went in and out to, in this case, Canada, but you can pick any of the GeoIPs. You can, if you want, import in ASN information and create host groups based on that, so you can see who's going to what ASNs, etc. So this allows you to know what's happening on your network and actually allows us to discover rogue hosts. Because if we have a bunch of addresses, RFC 1918, so the typical private addresses, and they've ended up in the inside host group's catch-all, that means that we haven't classified them as anything else. We don't know what they are, we don't know what type of device they are, therefore they're a potential rogue. So as well as giving us all the visibility of what's happening in the network, it allows us to drill down and say, okay, we don't know about these devices. The potential rogues, they may not be, it may just be that you don't have the full information, but they may be rogue hosts, so we want to have a look at them. So you can then drill down, see where they've been, see what their traffic patterns are, and work out whether or not they are a rogue host. The indicator of compromise, for those who don't use the term, is basically where we see something that is, as it says, a potential indicator that something is not happening quite the way we want, and we think that maybe there has been a compromise. And there are a number of different indicators of compromise, and there are a number of different ways that StealthWatch and NetFlow Analysis can help with those. You can see what the activity is, you can look at raw flow analysis, we can feed information into log analysis with your SIM. We've got a number of different ways, not just from NetFlow, that you can get indicators of compromise. And as I say, there are many different ways that need to be, many different sources that need to be pieced together. To look briefly at an attack lifecycle model that will show how we use some of these indicators of compromise. The initial recon happens, that creates the initial compromise. We've got an infiltration from a command and control server. There are some exploratory actions that happen. Then there's the expansion once the success of the command and control has happened. Then that creates a staging that generates the execution of either theft or disruption. Each of those will generate indicators of compromise, and we can build a map or a model of the attack and see what is happening and has happened. So there are a couple of things. Behavioral analysis. We can leverage known bad behavior. So if we see certain traffic patterns, we know that there is an address scanning going on. If we see certain traffic patterns between two areas that we believe we have got segmented, either by policy or hard segmentation, and we see traffic there, there's another indicator of compromise. If we suddenly see the behavior change, so if suddenly these host groups or these users are generating a lot of FTP traffic at 5 o'clock in the morning, when normally they're not doing any FTP traffic, let alone at 5 o'clock in the morning, there's an indicator of compromise. And one of the key parts within the StealthWatch is the network behavioral anomaly detection model. So we break the day down into 5-minute segments, and we create a series of baselines, effectively 28-day baseline for each host or each host group, and we monitor that behavior. The baseline is weighted more to the last 7 days than the previous 3 weeks, and we track and measure the behavior and feed that into the series of algorithms. If those algorithms trigger, they will generate security events. So if they see some suspicious behavior, they'll say, okay, there's a potential security event here, it will generate an alarm. Those alarms can come up either onto the alarm categories, which are high-level alarms, or you can use the built-in attributes of the StealthWatch system to forward these alarms as syslog messages, email, SNMP traps, or to run mitigation scripts if you wish. So each of those security events accrues in points and creates these alarm categories. And you see there, you can see what the total has been and what the current active alarms are. One of the alarms, for example, is the concern index. So this is the reputational score. So what we see here is we have got 2 devices with phenomenally high concern indexes. So you might well want to investigate further, because this is a significant indicator of compromise. You click down, you can drill down then into the underlying security events, and you can see what's happening, what the security events are, what's happened, what set them up, etc. You can also drill down onto the individual IP address. So this alarm is showing here. You can drill down on the IP address or on the user to pull out further information. Another example, watching for data theft. If we suspect that there's data exfiltration, that generates an alarm in its own right, and it could be either single or multiple destinations. One of the other things here is this is one of the security events that can be both based on policy and behavioral. So the behavioral is created automatically by the system. If it sees high levels of increase in data to hosts that it's not normally been talking to, etc., it will put that up as a potential data exfiltration. You can also set hard policies. So you can say, actually, if any of these particular devices in this host group or host groups ever connect to any devices or to the internet or to any other host groups, then that in itself is a breach of policy and needs to generate an alarm. And we have similar for data hoarding, target data hoarding or suspect data hoarding, essentially where we're collecting it in or sending it out. And again, these will generate alarms that you can drill down through. We've now got a lot of evidence in Sherlock's terms. We've got indicators of compromise or indicators of concern, depending on how we use the term. We're now going to actually investigate a bit further. So when we click down on one of those individual IP addresses in the previous alarms, it brings up a dashboard. It shows the alarms for that individual device. So this particular address has got 1 exploitation alarm and 1 concern index alarm. It gives us a quick view of where that host has been communicating. It's been talking to the outside world. It's been talking internally to these different host groups. We can see what alarms this address has had over the last 7 days. And we can get some summary information on the left-hand side about this particular device. And if we've got the integration with ICE, we can get the MAC address, etc., etc. We can then drill down. So say, okay, let's see who's been using this particular device, what sessions has it had. So we see here, user Betty, it's had a number of sessions. There's a number of different applications that have been running, and you can see those are for the 24-hour or 7-day. And we can see actually, if we drill further down, there's quite a bit of SMB traffic that is suspicious to us. So once we've got the indicator, we can then investigate, drill down and investigate quite detail as to exactly what is and isn't happening and get further information. Again, all coming up through the alarms that allows us to drill down. And it could be a specific user. So as well as drilling down on a particular IP address, you could drill down on a user name or actually just put a search into the dashboard and search for a particular username. This will then pull back information. So if we've got the integration with ICE or Active Directory, it will give us the Active Directory details, where they're in, their OUs, etc. It will show us what alarms this user has had in the last 7 days and the last 24 hours. It will show us the devices and sessions. And if we wish, we can click and drill down through into the individual user flows. And that will show us exactly where that user has connected to over whatever period of time, and we can filter that based on time, country, protocol, ports, etc. So where we've used NetFlow to pull through and give us the visibility of what is happening, we've then used that NetFlow information to produce indicators of concern or indicators of compromise, where the evidence, as Sherlock would say, and we can then investigate through the GUI, through the dashboards, drilling down to investigate what has happened, where they've been. We've got the contextual information from ICE, and contextual information from NBAR where available, etc. To all allow us to then take that evidence and say, okay, yes, we have got a problem here. No, we haven't had a problem, etc. It allows us to go through all that. There is a whole load of recommended reading and different links, which you can pull down and get hold of once you get the presentation. A couple of key takeaways from where we've got to so far, apart from don't worry, we're from the internet. Insider threats are operating on your network interior, and the perimeter defenses alone are not going to stop those. In order to have proper threat detection and a response, you've got to have the visibility of what's happening. That comes from the NetFlow, and ideally extra context from integrations with ICE, TrustSec, from NBAR, anywhere else that you can get extra information, the extra context. And that NetFlow and StealthWatch system combined will provide that actionable security intelligence that you require.